10.5 Conic sections, Part A. Conic sections results from intersecting a cone with a plane. So we have a cone and a plane intersecting the cone parallel to the base. Then this cross section here is a circle. Okay, so if we have a plane now intersecting the cone in such a way at an angle here, this intersection would be an ellipse, and another cone with the plane intersecting it at an angle more like that. That intersection is parabola. Okay, and I'm gonna look at one more case where the plane is intersecting both parts of the cone. So something like this would have hyperbola. Okay, and of course the plane intersecting the cone at this point here will be a point, and that's trivial, we're not gonna look at it. So part one, we'll be talking about parabolas. Parabola. So how do we define parabola? We defined it with a set of points in a plane. They are equidistant from a fixed point F. Which we call focus. The fixed point F is called focus, and a fixed line called directrix. So draw a picture. So a parabola, let's say it's opening up. So the fixed point F, the focus is right here, and the directrix, it doesn't have to be necessary the x-axis. So let me change that. Doesn't have to be the x-axis. So this is the directrix right here. It could be the x-axis, but it doesn't have to be. So this is our parabola, this is our focus directrix. So this point right here, we call it a vertex. And in this case, the parabola opens up, it can open down or to the left or to the right. So for convenience now, let's have the vertex coincide with the origin, and the directrix parallel to the x-axis. So we're going to have this picture here. We set the vertex of the parabola the same as the origin. That's the vertex or the origin, and the directrix somewhere here. So this is the directrix. the focus over here. So if P with coordinates x, y is a random point anywhere on the line, anywhere on the parabola, so P with coordinates x, y, it's anywhere. By the definition we just said, the distance from any point on the parabola to the focus is the same as the distance from that point to the directrix. So let's call that point here L. So we have PF, this distance, has to equal to PL. So let's calculate PF. PF, that is a hypotenuse in a right triangle here. So it's equal to x squared plus y minus p squared. So P is the distance from the x-axis to the directrix. So the directrix will have equation, let's write it down here, y equals negative p. So that's the equation of directrix. This is the origin. So if we have this distance p from here to here is y, and that would help us determine PL. So PL is equal to y plus p. Okay, so let's substitute these equations in PF equals to PL, and we'll have square root of x squared plus y minus p squared equals to y plus p. We're going to square both sides, x squared plus y minus p squared equals y plus p squared. And we're going to FOIL here, y squared minus 2yp plus p squared equals y squared plus 2yp plus p squared. Let's see what can cancel. The y squared canceled, the p squared cancels. So what we have left is x squared equals, move the 2yp on the other side, 4py. So this is the equation that we got for the parabola using our definition. So that's the equation of a parabola. With focus zero p. Let's go back to our picture. Our focus F had coordinates 0p, and directrix that's the horizontal line. The equation was y equals negative p. So x squared equals 4py. We can solve for y and have 1 over 4p x squared. And if we let a equals 1 over 4p, then 1 becomes our familiar equation, y equals ax squared, which we know from algebra. So if p is positive, then the parabola opens up. And if p is negative, the parabola opens down. So you have open up and open down. The graph is symmetrical with respect to the y-axis. So let's show the picture. In this case, we have the parabola opens up. This is the x-axis, and we set the vertex to be the same as the origin. Focus right here, 0, p. And our directress right here has equation y equals negative p. The equation is x squared equals 4py, and p is positive. Okay, if the parabola opens down, so we have this case, again the vertex coincides with the origin, so the focus is right here, 0, p. Directrix right here has an equation y equals negative p. Our equation is the same, x squared equals 4py, but in this case, p is negative. We're familiar with those two cases. Now, if we switch x and y, we get y squared equals 4px. Again, that's an equation of a parabola. In this case, the focus would be p0, and directrix will have equation x equals negative p. So let's look at the case where again the vertex is at the origin. The parabola, it's going to have a graph that's not a function. It's still parabola. The focus is right here, p0, and the directrix has equation x equals negative p. So this is y squared equals 4px, the case where p is positive. And last case, where the parabola opens to the left, the focus is right here, p0, the directrix to the right, with equation x equals negative p. This is the x and the y-axis again. And our equation is again y squared equals 4px, but p is negative. So example, find the focus and directress of the parabola. With equation y squared plus 10x equals 0 in sketch. So we have the equation y squared equals negative 10x, and that matches with our second equation, which is y squared equals 4px. So 4p is equal to negative 10. Solve for p, negative 10 over 4 or negative 5 over 2, it's negative. So our focus will have coordinates p0 or negative 5 over 2, 0, and directrix with equation x equals 5 over 2. So p negative means parabola opens to the left, just like in our case over here. So to sketch it, we sketch the focus, -5/2, 0, and the parabola opens to the left. Not easy to graph this. Okay, here you go. And the directrix, vertical line with equation x = 5/2. So this is at origin 0. Number 2, we'll talk about ellipses. This is another conic section. Definition: it's a set of points in a plane, the sum of whose distances from two fixed points F1 and F2 called foci is a constant. These two fixed points are called foci. So let's have a picture. We know what an ellipse looks like. And we have two fixed points, F1 and F2, called foci. So if I have a random point anywhere on the ellipse P with coordinates x and y, the sum of these two distances, we'll call this d1 and d2, this is constant. So that's what definition of an ellipse is. Very similar to the circle. In the circle, you have a set of points whose distance to one fixed point, the center, is constant. Now we have two fixed points. So let the foci be F1 with coordinates -c0 and F2 with coordinates c0. So we want the two foci to be on the x-axis. So here is first one and the second one. F1 -c0, F2 c0. So our ellipse looks like that. We have a fixed point P on the ellipse. So to make things easier, we center the ellipse at the origin, so it will be easier to do math. Now we have this distance, PF1, so PF1, plus this distance, PF2, to equal to a constant. Let's call that constant 2a, 2a positive, just for convenience. So now let's express PF1 as a hypotenuse in a right triangle. So PF1 is a hypotenuse in this right triangle, so it's equal to this squared plus this squared. This distance over here, this one, is y, so we can have y squared, and this distance from here to here is c, and from here to here is x. So we can have square root of x plus c squared plus y squared for PF1, and that we're going to add PF2 in the same way. This is x minus c squared plus y squared. It's really easy to see this from the right triangles, both of those are hypotenuse, and that's equal to 2a. So now we are going to move this term on the other side and rewrite this as square root of x minus c squared plus y squared equals 2a minus square root of x plus c squared plus y squared. And we're going to square both sides. Okay. So now we have x minus c squared plus y squared equals 2a squared minus 2 times 2a times the square root. There's going to be a lot of algebra here to derive the formula, and finally plus. Okay, I'm not going to be able to fit it here. Plus x plus c squared plus y squared. Here you go. Okay, so after simplifying, combining like terms, and grouping, we'll get an equation of this sort. A squared minus c squared x squared plus a squared y squared equals a squared times a squared minus c squared. So check the calculations here. Now, if we look at triangle F1, F2P, we see that 2a is less than, 2c is less than 2a, or c is less than a. So let's look at this. So 2a is the sum of PF1 and PF2, and 2c is from F1 to F2. We know in a triangle, the sum of any two sides is bigger than any of the sides. So it's a triangle inequalities, that's where we got that. So we have a squared minus c squared positive, right? If a is greater than c, then that is a minus ca plus c, so that's positive. So we're gonna let this a squared minus c squared equals to b squared. And I'm gonna rewrite the equation above as b squared x squared. So what we're doing right now in this a squared minus c squared, this is equal to b squared. So we have b squared x squared plus a squared y squared equals a squared. A squared minus c squared is b squared. So that is b squared. Again, this one is equal to b squared. And finally, divide by a squared b squared. And we have b squared x squared over a squared b squared plus a squared y squared over a squared b squared equals a squared b squared over a squared b squared. We simplify, cancel the a squared, b squared, and what's left is x squared over a squared plus y squared over b squared equals to 1, which is our familiar formula for an ellipse. So we'll call this formula 4 to follow, that will be 3 to follow the notation in your textbook. And now we're going to draw a picture. So for convenience, we decided to have the ellipse center at the origin. And now we have this point here is A, or A0, and this point is -8, 0. This point over here is 0B, and negative and 0, -b. How did we find those points, which we call vertices? By finding x and y intercepts. So if we say y equals 0 in the above equation, we'll have x equals plus minus a. So those are the x-intercepts. And if we say x equals 0, we'll have y equals plus minus b, and those are the y-intercepts. So we have the foci right here, C0 and negative C0, so F1 and F2. So we have vertices, we have foci, we have a major axis, so this is a major axis. Major axis is the axis along which the foci are located, and this is a minor axis. Minor axis. Okay, so we have the foci, C0 and negative C0. We have the vertices labeled. We have c squared equals a squared minus b squared. Very important equation, a is greater than b. Okay, so if the foci of an ellipse are located on the y-axis, so let's draw a picture of an ellipse. It goes this way. So now the major axis is this axis. So we have this point here, 0a, 0, negative a, b0, and negative b0. The foci along the y-axis here, so that will be 0c and 0, negative c. So in this case, the foci are 0c and 0, negative c. Then the equation becomes x squared over b squared plus y squared over a squared equals 1. Again, c squared is equal to a squared minus b squared. So basically we switch x and y, everything reversed. Example, sketch the graph of 9x squared plus 16y squared equals 144. That equation does not look like any of our equations, so we are going to divide by 144 because we want to have 1 on the right side. So 9x squared over 144 plus 16x squared over 144 equals 144 over 144. Simplify, and we have x squared over 16 plus y squared over 9 equals 1. Now that looks like equation of an ellipse, and we can determine a is 4 and b is 3. C squared is equal to a squared minus b squared, and that is 16 minus 9, 7. So c is equal to square root of 7, and the foci are square root of 7, 0, negative square root of 7, 0. Vertices, they would be along the x-axis, 4, 0, and negative 4, 0. And we are ready to sketch the ellipse. So here are the foci, root 7, 0, negative root 7, 0, and the vertices, 4, 0, negative 4, 0. All right, another example. Find equation of an ellipse with foci zero, plus minus 2, and vertices 0 plus minus 3. So if they give you the foci and you notice they are along the y-axis, this is one of them, and this is the other, that means your ellipse is going to be this way. The vertex is also given, so that is 0, 3, and 0, negative 3. So A is 3, that's a major axis here. A is 3, and C is 2. We can find B from the equation C squared equals A squared minus B squared. 4 equals 9 minus B squared, and B squared is equal to 5. So we can write the equation of the ellipse x squared over b squared, which is 5, plus y squared over a squared, which is 9, is equal to 1. We can also multiply by 45 both sides and have 9x squared plus 5y squared equals 45. So either equation is fine. And that concludes part 1 or part A of the video.